I hope everyone is doing well. Thank you so much for joining us today. My name is Jeff Chapman. I'm with the marketing team here at InOrbit, and we really appreciate your time coming together today for this, what's going to be a really exciting webinar. This is AI-powered multi-robot orchestration, and we are, of course, InOrbit. So maybe we should have even called this multi-system orchestration, really, because orchestration to us really entails working with partners and integrations across really disparate systems to make these technologies come together. If you're unfamiliar with InOrbit, we are an AI-powered, secure, cloud-based robot operations platform and data management. So we go beyond simple fleet management to encompass, really cover RobOps, which is more than just orchestration. It really involves observing, visibility of all of your systems through a single screen, ideally. Orchestration, of course, so that's everything from your traffic management to beyond with varying systems. Operations, managing the day-to-day of everything that's happening. That includes incident management, remotely understanding what's happening at scale as a robot and expanded automation fleet grows. And then of course, optimization, which really ties back into the larger data question around robotics. And that's kind of really central, I think, to how we're also approaching the AI integration and how that can help drive smarter robot operations, if you will. So a couple of quick housekeeping notes as we get started with today. This webinar will be 45 minutes long. We are recording it. I did start the recording. So we are recording this webinar. So if some of your colleagues might be interested in these topics and didn't get a chance to join in, please, we'll send out a video link after the fact and you can share it with anyone you like. And then if you have any questions, feel free to type them in the chat and we will try to address them at the end of the demonstrations and conversation sort of portion of the webinar. Of course, if you have additional questions afterwards, feel free to reach out to us. We're always available and here to talk. We have some really exciting things on deck today, though, and some really great partner technologies as well that we'll be showcasing. But I think with that, my role here as the MC is done. I would love to introduce you to your host and our speakers for today's webinar. Please join me in welcoming InOrbit CEO and founder Florian Pestoni, alongside InOrbit's VP of Operations and Technology, John Simmons, and InOrbit's new CEO, Ramiro Diaz Trepat. Gentlemen, thank you for joining. So glad to have you here. And Ramiro, your name is listed wrong, but that's okay. I'll take it away, Florian. I'll leave it to you.
Fantastic. Thank you, Jeff, for being the always consummate host and MC of this event. Let me just get going on our presentation. Oh, sorry, I'm getting some buffering. Apologize for that. There we go. So I think you heard Jeff mention about RobOps or robot operations. Our goal is to help unleash the value of every robot wherever they are and help people grow their use of automation. So if we take just a quick step back, I think we all understand, if you're in this webinar, you probably already know this, the role of AI and robotics and how we work. So you can think of InOrbit as the robot operations platform that on the one hand makes the robots work better, but also makes the robots work better together. So regardless of vendor, regardless of task. And one of the things that I think is very exciting about what's happening in the industry is that this concept of software-defined automation for physical tasks is now entering all kinds of industries. Manufacturing has been the traditional domain for automation, but now you see them in logistics, you see them in hospitals, out in the field, literally in retail stores. So I think it's really exciting how the notion of automation is expanding and this growing role of software. And I would say our approach has been to, we don't build the software that runs the enterprise. We don't build the hardware or the software that runs the robots themselves. What we try to do is connect everything. So you can think of it as this messy middle where automation technology has to integrate with software that perhaps wasn't created for that purpose. So we handle a lot of that complexity across all of these different types of hardware solutions. Now, if I think about an end user, a company adopting robots, they have to go through this journey, right? And a lot of times it starts small with a proof of concept with maybe a single robot. If that's successful, you may expand to a pilot project. But once you get into production, you're eventually getting into many robots, possibly across different sites, especially for global companies that have a presence maybe across the world. And then soon enough, you're like, okay, so I have a robot for this one task. What else can I automate? And once you get into that mode, you find more and more opportunities. Now you can tackle those independently, but what happens is you actually have a job to do, right? You have a workflow, and that's really, you're hiring the robots to do the work. So they do need to work together. So I think that's where orchestration comes in, and you can start with the basics, coexistence, don't get in each other's ways, and all the way to collaboration, where in order to complete a task or a mission, you may need multiple robots to collaborate. So with that, a big part of what we're doing is approaching this from an ecosystem perspective. And we have this growing ecosystem of partners. And what I wanted to do today is highlight some additions that we have in terms of real-time location systems. So I'm really, really proud to announce that we're working with some of the leaders in RTLS. SICK is a company that's known to everyone in the robotic space, but also a lot of really innovative companies like Slamcore, Argo, Guide Robotics. What they can do through different technologies and different approaches is expand the ability to track things other than robots, including robots, but expand the universe. So let me talk a little bit about these varying technologies and how they fit. I think the reality is, in a lot of scenarios, you're going to have a hybrid fleet of autonomous and manual vehicles, usually sharing the space. So for example, in a production facility, there may be a road which is safe for every vehicle to run. And in some cases, you may be able to designate, let's say, a lane for your AGVs, but soon enough, all of this ends up kind of trying to coexist, and they can't all be in the same place at the same time. So when you think about this diagram, you can think of the different localization and navigation technologies, but also how much autonomy something has. So if you think about a manual forklift, step number one is, where is it? So that's the localization. If it's an autonomous forklift or an AMR or an HEV, now it has more agency, right? It has more autonomy. So I'm sure different people will position these boxes slightly differently, but I think the concept is, how do you combine these two areas in a single, a single pane of glass? And that's where integrated traffic management comes in. That's something that InOrbit can do, where you can combine different robots from different vendors, and now you can also include manual equipment. It could be a forklift, it could be a cart, it could even be people. For example, you can track the safety equipment that they wear to understand kind of the pattern of flow of people alongside the flow of robots and vehicles. And then lastly, we're going to cover today a little bit about this concept of AI-powered optimization. And we're showing something that's really, really unique, which is not just capturing data, but understanding data. In this case, we're using visual data. And the whole idea is, how can I, as someone trying to optimize the flow of goods through my facility, how can I understand what's getting in the way? So we'll go through all of that, and for that, I'd like to pass the baton to John.
Thanks, Florian. Excuse me. All right. Can everybody see my screen now? All right. So quickly, I want to introduce InOrbit just for a little bit and kind of give an overview of what looking at control looks like and the purpose, and then we're going to dig into a couple use cases for these technologies. One thing I want to call out that we're going to touch on today is, and one of the reasons why technology such as RTLS is important, is introducing robots into existing facilities is almost never a greenfield type of problem. It's a brownfield problem. There's existing infrastructure and logistics which are critical to be able to integrate with, rather than just a clean slate where robots or automation can be brought in and set up without taking into consideration all of that existing infrastructure that is helping the facilities run. So we'll look at a couple of use cases with how that can work, and also some of the problems it introduces and how a solution, a robust platform like InOrbit, can help solve those problems. So here we're looking at our executive dashboard. You know, a lot of facilities or a lot of companies introducing robots are going to have facilities scattered across the world. And the executive dashboard is just a simple way to provide a heads-up overview of how things are performing, top-level KPIs, and those types of things. But more interesting, typically, is coming and looking at the performance of the fleet itself. And here we have a customer, they're called Brickmart, and they have a lot of robots doing a lot of different things, spread across a lot of different facilities. With InOrbit, you can easily look at, you know, where are these robots, where are things working well or not, and understand the incidents and what's happening within your fleet. Let's dig into this a little bit, and we'll look at a specific location for Brickmart. And we can easily look at the different types of robots. This is a perspective that we call unified fleet. And unified fleet is about bringing together into a single pane of glass the ability to understand different types of automation technologies that are within a facility. And here you can see that we have robots that are picking robots. We have IoT devices, some manual devices, and we can see the health of all of those quickly here in this one single view. Now we're going to step in a little bit. And before we kick off this demo and talk about how to orchestrate these different things together, I'll set this up a little bit. What you're looking at is a retail space where you know, we have different robots performing different tasks, and one of those tasks is a restocking task where we make sure that the product out on the shelves is okay, and we have different devices here. We have robots, we have carts to just help us move different things around. One of the challenges is tracking where these carts are, and as they have to move between spaces, such as here, you'll see there's a door here that we have to be able to navigate across. In this case, we're working with one of our partners, SICK, who has ultra-wideband RTLS technology, and that can let you easily and very cost efficiently track the location of devices that don't have any technology on them. They don't have a computer, they don't have a navigation stack and sensors. So we can use RTLS type of technologies to make that work more effectively. So let's put our robot to work here. We want it to go up to the front. There's going to be some restocking to do. And so I will launch it on a mission directly from our interface. This obviously missions can be launched through multiple mechanisms. And that can be done either through manually launching on a mission like I have just now, or through a systems. And here you can see there's a cart coming through this door. The robot, we need it to pause so that it doesn't get in the way of that cart that's coming through. And we can know that that's happening because of the RTLS integration back to control. And if we switch back to this view, you'll see that the carts come to the back. The robot's paused here right at the edge of this single occupancy zone. And now that the zone has cleared, it's going to go about on its way and complete the task that was given to it earlier. And again, the reason why this is important is that RTLS technology makes it effective to understand not only where are our robots, but also where are other things within a space. So imagine a e-commerce facility or a manufacturing facility. There's a lot of equipment in those facilities that isn't tied directly to a robot that can report its location. And so by leveraging RTLS devices, we can more easily understand where are all the devices in the space, and we can optimize the traffic management and the performance of all of those devices. And now as I'm looking at this robot, I see here that it's stopped not where it should have been. So I want to go back and we'll take a look here, and this is an IoT camera that can look in the space, and I can see here that the robot didn't make it to its goal. Using control, I can easily ask the IoT camera to look in a different direction, and sure enough, somebody has left a pallet with some boxes here in the way of where the robot's trying to get to. We'll come back and take a look at this in a little bit later in a bit more detail and understand how we can help with problems such as this as well. But first, I want to transition over to another use case and another RTLS type of technology and explore that one for a little bit first. So stay tuned here. Okay, so coming to a different location. So this is still Brickmart, but in addition to retail stores, they have warehouses and different types of to ship and fulfill all of their equipment to their retail stores, distribution centers, something along those lines. And so one of the challenges that we often see and hear about from our customers in warehouses is that things like forklifts and other types of technology used to move things around in those facilities is problematic, because as AMRs or AGVs are trying to navigate through the space, they can often run into roadblocks or get in the way of forklifts coming through a space. And as you know, anybody that's worked in these type of situations, something that they will always say is that when a robot meets a forklift, the forklift wins. And that's a very expensive situation that they'd like to avoid. So we'll set this up a little bit here. What you're looking at is a warehouse. This system over here on the left is an ASRS system that can provide different product picking and that type of capability, some picking robots. And it looks like we've got a floor cleaning robot that has had trouble navigating, and that something's been left in the way. And I can see here, in fact, that it reached the edge of an occupancy zone. And now we have a forklift that's has been left right in the way of where the cleaning robot needs to go. And until that forklift is moved, InOrbit has been able to identify that this space is occupied, and now it needs to be, until it's cleared, then the cleaning robot is told to hold where it is, that the space isn't free and isn't available. for cleaning to continue. But now, as we can see here, the forklifts have been moved out of the way, and in fact, as soon as that happens, the robot, without any interaction from a person here, is allowed to go and continue, and we can see it heading towards the back now and finishing its route. This particular RTLS technology is not ultra wideband. It's with one of our partners called Slamcore, and they can specialize in camera-based RTLS capabilities, which is just one of the many other mechanisms that we can use to track, as I said, non-smart devices that exist within warehouses and manufacturing facilities. Okay, now as promised, we want to go back here and look at what happened earlier in the first location, our retail location that we're talking about. We can see a pallet here has been left in the way of our robot that couldn't reach its goal. If I come back and look at this robot here, in fact, I see that an incident was triggered, and this incident tells me that the waypoint was blocked and that the robot wasn't able to complete its task. This incident could have notified somebody, maybe in the facility, or perhaps in a remote location who could investigate the cause. And now what I'd like to do is hand this off to Ramiro, who's going to talk to us a little bit about not just understanding that an incident has happened, one incident, but the power of leveraging modern AI technologies to understand these incidents better, and then to explore them and really optimize the performance of a fleet of robots across locations, leveraging that understanding that AI can accelerate for us.
Thank you. All right. Hello, everyone. I'm Ramiro, not Rosina. I hope you're all right. I wanted to tell you about how, as John mentioned, we're leveraging AI to deliver concrete value to every possible part of the process involving robot orchestration. Specifically, we will be showing today how we use AI to get insights into robot incidents. So from a fleet manager of InOrbit, you can select one robot to see your incident list. And I will grab one incident where the waypoint was blocked. And I will open Time Capsule, which is the tool that we use to analyze and replay all the events that happened during an incident to gather insights and try to make things better in the future. So in this incident, normally you have a timeline where you will be able to replay and see all the sensor information and the camera data and the position of the robot as it moves in the map. What we've added now, what you're seeing is actually a part of our product that is in beta testing, I would say. It's not fully productized yet, but it's an AI summary of the video that will give you in a quick glimpse a summary of what happens in that time interval from the perspective of that robot's cameras. It will not only give you a summary, it will give you a breakdown of the events and the time where the events happen. It will also detect the objects that the robot came across. So you can see here what the camera was looking at that moment. You can click on an object, and if I click on a pallet, you will be able to see the exact moment in the time capsule what was going on when the robot came across the pallet. We believe this can make getting insights much faster when you go to look into time capsule about what happened during an incident, you can very quickly, you will be able to very quickly see here if there is an object that shouldn't be there, or detect in the summary, in the breakdown of events, if there is something that can quickly take you to that instant and give you a faster way to understand what was going on. Besides that, we have integrated the object detection to ROBOps Copilot, which is our RAG tool, our AI tool, where you can ask all kinds of questions about your fleet status and its past. So if you find a problem, say something more odd, like or what we just found here, a robot had a waypoint block incident because somebody left a pallet where it shouldn't have been. If you're wondering if this happens often, you could ask Copilot, like, show me all incidents where a robot sees a pallet. And this query should bring me up. Here is a list of all the incidents with a link to their respective time capsules, and the moments when they start, and the severity, where robots came across a pallet. With this, our idea is that you can see if a problem you're facing is frequent enough that you should take an action to solve it for good and make your business process more efficient as a whole. And that's what we wanted to show to you today about AI. This includes, to do a small recap, interpretation of videos using computer vision, object detection, moment detection, everything integrated into time capsule, and also generative AI to understand you in natural language, to get your questions answered from the InOrbit's database about your fleet management, and that includes the objects that the robots have seen that are now part of the telemetry of the robot.
This is fantastic, yeah. Ram. Let me chime in with a comment. So I was recently on a panel, and it was with someone from a facility where they want everything to be very tightly orchestrated, tightly controlled. So I think there's, the more traditional line following AGVs. I think if you operate in an environment where you can control absolutely every aspect of it, that's certainly something that that can be handled. But I think, as you're showing here, you're running 11,000 missions across different facilities. Something is going to go a little wrong unless you can control every aspect of it. So I think this is there's the platonic ideal of fleet management where everything is in the right place at the right time and there are no obstacles or anything you don't control. And then there's the real world scenarios where somebody left a pallet in the wrong place. Mm-hmm. Sorry, I wanted to chime in with that to kind of like help frame how people think about automation in general.
Yeah. Moreover, to what Florian is saying, I wanted to show you also the traditional tools that InOrbit provides to filter missions. And if I filter mission by location here at robot space 293, and I group them by hardware, I have the option to see KPIs in general and how it's another way to connect the insights you may get from the time capsule to go deeper into a specific location and see the KPIs in general about the performance of your operation.
I think that's really cool, Ramiro. And one thing I want to tie this back to is something that Florian said at the beginning when he kicked us off, which is investments in automation aren't because robots are cool. As cool as robots are, people don't spend a lot of money on robots because they're cool. They're spending money on those robots in order to get work done. And when you're introducing modern technologies into existing facilities, it's going to happen that you're going to run into the need to optimize not just the robots themselves, but the overall workflows of those facilities. Being able to measure that and leverage tools like computer vision and generative AI, RTLS and orchestration together in an integrated mechanism in a single pane of glass to give operations teams the ability to know which facilities are performing well, which ones aren't, which hardware models maybe need some attention, or which processes are leaving things in the way of robots trying to complete work, and those processes need attention to be adjusted. That is critical for the ability for us to continue expanding the robotics ecosystem into more and more and more industries and use cases.
Indeed. I want to emphasize again something that John was showing just before. I think everybody knows that the vision in InOrbit is to be robot agnostic and be able to operate a business with multiple robots from different brands, because that is the reality. What we've shown today, incorporating other vehicles that are human-driven to that orchestration, it's really something new, something fabulous. Being able to make a robot respect single occupancy zone when a human-driven vehicle that is unaware of that zone just drives through it, really adds value to the whole operation to make things run more smooth and safer. To me, that's
I like the example with the door, where I think we saw it from the point of view of the robot, but imagine the person pushing that cart, and you are walking up to a door and you open the door and there's this hulking robot on the other side, and you may or may not know what it's going to do. So having the robot just patiently waiting for you to come through, and then as soon as you're past that zone, it continues on its way. Again, that's a different type of orchestration where things aren't as tightly coupled as you might find in some other situations. And I think that's becoming more and more common. I mean, InOrbit can also do the more traditional traffic management, but actually, since you have this up, if you go to navigation, being able to annotate a map with zones and waypoints that are shared. Actually, you need to change the map. Yeah, so that's what the robot sees. This is what a human would see, and in layers you can add zones, for example, and then now you can. This is something that any user can do directly in the UI, and now all of a sudden you're starting to get a lot more context about what's happening. And although you can get that maybe from individual vendors having this in an integrated fashion, and now working with these manual vehicles that are being tracked, I think that changes how you run your facility in this case.
Right. I will stop sharing now, if that's okay.
Yeah, Jeff, I'm wondering, do we have any questions from the attendees that now would be a good time for us to answer?
Hey guys, yeah, I haven't seen anything from the attendees specifically, but if anyone does have any questions, feel free to ask them. I would love to get a bit more info though, Florian, one on, and I know you were just
I think we lost you, Jeff.
this, but for zones, I mean, I think it'd be interesting to sort of, that's just how easy it is to build zones now. Did I break up there? Did you hear me?
Now you're back. You sounded
Did
like
you hear me, Florian?
for a second.
Okay, I'm so sorry, everyone. Yeah, that makes sense. Okay. No, I was wondering if Florian, if you could talk about one of the upgrades, advancements we've done in zones. They're so much easier to build now. I think that for anyone on the ground level operating, like that's a huge win to quickly discuss if you don't mind.
Yeah, I think so. Again, I think it goes back to the discussion about are the robots operating in a tightly controlled, never changing environment, or is the environment more dynamic? And in a dynamic environment, things change place, right? You can't just define where something is and then count on that being there forever. If you're building a production line, yeah, maybe your cells are not going to be shifting randomly. But for example, in a retail store or a warehouse, there's always shelves being moved around. So being able to go in and make a change dynamically, and then that impacts every one of your robots, regardless of vendor, I think that's pretty powerful. These zones can also have roles assigned to them. So we saw an example of what we call single occupancy. It is basically what it means, one robot at a time or one thing at a time now that we can track things besides robots. And I think that's as simple as it sounds. It's extremely powerful to handle kind of like casual collaboration. You saw, for example, that cleaning robot entering a zone, and turns out there's this big forklift in the way. So being able to coordinate that zone can be redefined very easily. The roles can be redefined, and you can even create your own roles through our API. So I always like to mention InOrbit is really a platform that allows people to build the specific workflows or the specific experiences that they need for their business. They're going to know their business best. So our job is to make it very, very simple, maybe a couple of clicks, a few lines of code, and all of a sudden you're redefining the behavior of all your robots without having to go kind of one by one, or maybe call back your systems integrator that set them up in the first place.
Right. And that's interesting because I think that also speaks to, people, our users know their business best. I think that the broader sort of ecosystem discussion really comes into play when I think we're talking about RTLS, and a lot of people are still new to the technology and understanding how to approach it. And I think that if you want to work with us, we're trying to give options for people to choose what solution might work and fit their facility best. But to that end, do you have any thoughts on approaching RTLS and how, maybe further that, how does InOrbit work with, and I know the answer to this, but how does InOrbit work with native RTLS support software? And I think that probably is similar answer to how we work with fleet management. But could you speak a bit to that?
Well, I can kick it off, and I'm sure John or Ram will chime in. I think the way to think about RTLS isn't just one technology; it's the ability to know where stuff is, right? I mean, if you go down to basics, we've been able to do that with mobile robots for some time. What is now interesting is that these manual vehicles can also be tracked together. And the way InOrbit works is, instead of trying to make everyone comply with some common definition, we can translate from one system to another and essentially put them all on the same map. By the way, we also support kind of emerging standards like VDA 5050 and mass robotics and others. So that's great. We're an active part of that community. But I think the reality is getting everything on exactly the same system for every purpose is really hard. So again, what you saw today, for example, when Ram was showing the native map of the robot, that's what each robot sees, how it sees the world. And now we're adding the ability to have, to put other things on the map. And whether it's, using VSLAM, Visual SLAM, which is something that a lot of robots actually use. By the way, if you have a Roomba, it uses VSLAM. Or ultra wideband changes the dynamics where now you have some antennas that are placed, but the individual tags are very inexpensive, so you can track lots of things.
Yeah, so let me jump in with from an operations perspective, some of the challenges that these technologies are helping customers address. So you can imagine a retail store or a warehouse has an incredible amount of moving things. Some of these things are tools, infrastructure like grocery carts or carts to carry items in a warehouse or materials in a manufacturing facility. Some of them are people. Some of them may be automated and some of them are not. And this presents incredible challenges to customers as they are trying to introduce robots into those types of facilities because robots don't handle things moving around them very well by design. They use obstacle avoidance to make sure they're not running into things and causing all the problems that can create. So when you introduce the ability to know where those robots are, but not only where the robots are, where all the devices, all of the things within a facility are, that creates incredible opportunities for designing the workflow of whatever needs to be happening, whether that's moving goods from intake to output, whether it's identifying in a retail space that there's a lot of activity in one side of a store and we shouldn't go clean. We shouldn't send the cleaning robot over to that side of the store right now because it wouldn't be able to do its work. All of these things were real challenges before, and you ended up having customers kind of cordoning off their robots into special areas. And that's clearly not optimal, right? It takes a large amount of manual effort in orchestration. Orchestration performed by a person, manually putting rules into place, which are then hard and fixed rules, and they can adapt to the current environment of a space. Now with these technologies like RTLS, zones, as Florian was talking, the ability to define software-defined rules around those zones to control how things behave given on the current situation, current location of things is really incredibly powerful.
And if I can chime in, Jeff, with one comment on the role of AI. I think we've seen robots use computer vision and path planning and a lot of this for some time, especially with AMRs. What we're adding is this extra kind of outside the robot processing, and that allows us to integrate all of these different perspectives that you might get from individual robots. And now through the power of AI, they're actually able to find out about your space dynamically, right? What's happening? Where did somebody leave a pallet? And then again, in a dynamic environment, those things happen all the time.
Well, I just love that I can actually it'll identify, and I can have a conversation with it like, oh, well, okay, so you've identified these are the three most logical sort of things that it saw on its path. Well, we can eliminate that first one, and now I can really zone in very quickly on what what maybe is causing my autonomy incident, what problems may be in place, and gain those insights into optimization like way quicker. Shoot, I realized we're hitting our time, unfortunately. Sorry, Ram, I really wanted to get more into the AI end of it with you, but we don't have time, unfortunately. If anyone has further questions or would like to see this in more depth, please feel free to reach out to us. We're always happy to show more. So with that, I think we are at our wall. Thank you very much for joining us, everyone, and we'll see you next time. Okay, so long. Have a great day, everyone. Bye-bye.